An ellipse is, and I have a hand up for you guys on a lot of this stuff. You don't have to write all this stuff out. No, I just want to show you what an ellipse is. Like I said earlier, an ellipse is a squished circle. All right, it's oval. Now, within an ellipse, there are a pair of foci, the multiple of focus. There's also vertices. There's two vertices. And just like with a parabola, a vertex always opened up towards the focus. It does the same thing here. The vertex would be here, opens to its focus. There's another vertex here that opens to its focus. What makes an ellipse is the fact that the distance from any point that's on the ellipse to the focus, the sum of those two distances is always constant. That's not something you have to know or show or prove. Could. Mr. Seb would make you, but it's really not that difficult to do. It's a lot of perpendicular stuff that you have to come up with, but we're not going to worry about proving that out. All it's saying is that from any point on the ellipse, the two distances to the focus, wherever that moves, that distance stays constant. Yeah.
Is it equal to
the distance between the foci? That's a lot of people ask. Sorry if I cut you off.
What are the foci again? Are they on the circle, like on the edge of the circle? No.
No.
So like where the like the line, like
yes.
the horizontal line, is that equal to A plus B?
Not necessarily.
Because up there.
Just like your phone.
Oh yeah, that Fred does that. Oh, I see what you're saying. Yeah, it's just I see what you're saying. Is it?
It shows like it.
I think it is. It might be. Oh yeah.
You learn something new in math every day.
I think it is.
Even after you've been
I don't remember.
years
It's
of
been so long since I had to prove anything off of it. Now, here's where the ellipse goes then. This is the ellipse. Okay. Here's where this goes. It goes to this.
Oh, is it just the things?
Yes. Let me show you what this means.
It's like two different square things.
It's kind of like
The halves face away from each other.
the halves will face away from each other. Those are called hyperbolas.
Oh, so that's it.
That's one. Okay. So here's what I wanted to talk about. When you're looking at an ellipse, there's one of two things that happens. And you guys have the notes coming out to you. Would you leave one for Jake? Okay. So one of the things that you'll notice, there's only two types of an ellipse. They're either squished left and right, or squished so they go up and down. Does everybody see that?
Yeah.
Now, in order for us to identify which one is which, it's very, very easy. What happens here is that you get these two generic formulas for an ellipse. X squared over A squared plus Y squared over B squared equals 1, or X squared over B squared plus Y squared over A squared. In order to tell which one is which, it's nothing more than which number is bigger. Which one has the larger denominator? A squared is always bigger than B squared. So if the bigger number is underneath the X, it's switched left and right. If the bigger number is under the Y, it's switched up and down. Switched, swished, excuse me. That's how you tell the difference. It is very, very easy when I threw numerical stuff at you guys. What I want to show you, though, more specifically, is what these parts mean. Obviously, in your graph, let's just take one little chunk of it. I'm going to look at just the horizontal one for right now. And blow it up. Maybe. There we go. What I want to show you guys is what these parts mean. And these parts stay the same whether it's an ellipse or when we get to hyperbolas. Okay? Even when we shift them. This value of A, here's my center. The value of A is always the distance from center to vertex. It's always the distance from the center to the vertex.
And is that
What's that?
never mind.
Our centers today are going to be located at the origin.
Okay,
Okay.
but, so that works for both of them?
Yep.
Okay.
When you say A, is that like the letter that's always used, or?
Yes, for these things, this A value is always going to be used for your distance from your center to your vertex for a conic. Whereas the B value is always going to be the distance from the center to what's called a covertex. So my B value goes this way. So here's B, here's A. And then obviously when I'm going left, it's the opposite of A, and when I'm going down, it's the opposite of B. Yes, ma'am?
When you say conic, is that just from the origin, it's not on the origin?
Conic is what I'm talking about, these curved figures, ellipse or a hyperbola. Okay. Does that make sense for A's and B's?
So, the B will always
The
be
B-
smaller than the A.
B will always be smaller than A, and here's a nice, easy way to remember the difference between A's and B's. President, vice president. Who has more power? Who comes first in the alphabet? A goes with the more important, B goes with the less important.
Is the distance from the center to vertical?
Yes. Okay? It's a very easy way to remember that. Now, this value of C, is always going to be the distance from the center to the focus. And the way that I remember that is because there's a C in focus. Yeah, exactly. And notice how my vertex is again opening to my focus. That hasn't changed. Just like with parabolas, that doesn't change. It doesn't change with these. It won't change with hyperbolas. My hyperbolas will open up to the focus as well. All right? So what you were able to do here then is by knowing how to get your A's and B's, well, how do you find C? With ellipses, in order to figure out the C value, it's always the same formula, whether it's stretched left and right or stretched up and down. Your C value is always found by taking C squared will equal A squared minus B squared. Because A squared is always bigger than B squared, that's how you're going to find it. No, B squared does not always have A squared. All right. Now, what I want you guys to see is notice how everything is written out in terms of A squareds, B squareds, and now I have a C squared here. You're going to be taking some very simple square roots. Working with them squished left and right or squished up and down is the exact same process. And it is very, very simple. Let me show you an example of how to graph and label all the parts. Okay? Let's do this. I want to graph 9x squared plus 16y squared equals 144. It's out of the way. What's that? When we get to the very end of, today I'm going to tell you graphing ellipses. Eventually, I'm going to show you, after we're done with learning all the different types that we're working with, I'm going to show you guys how you're able to distinguish between the types. And it is very easy to do so. But I don't want to give you too much information up front. So, according to our little generic formula that you guys have on that sheet in front of you, the formulas for the ellipses always equal 1. Would you agree? And they always have fractions, right? So I want to make that equal to 1, and I'm not going to subtract 143. What am I going to do? By what? Exactly. Divide everything by 144.
Whatever you say.
You always want to make it equal to 1. And I was jokingly saying I'm not going to subtract 143. Ah,
I still don't get why we won't do that. Then we'll
So now I want to simplify my fractions. 9 over 144 becomes x squared over 16. 16y squared over 144 becomes y squared over 9. And what's 144 divided by 144? That was 144 divided by 144.
Were they all gonna come out this cleanly?
Wait, I'm the one that did that.
Uh-huh. This becomes, if you take 9 over 144, it becomes 1 over 16, which I have right there.
But why don't we subtract 1
Because you have to have a fraction.
Oh.
Okay? And you're asking, do they always work that clean? More often than not, they work out pretty decently. More often than not, these work out pretty decent. Yes, sir?
So does that mean, will it ever, like, do what this one did, which the numerator also becomes a denominator?
It's dumb luck that it happened in this case. They're not always just reciprocal of one another. They don't always work that nicely. But for the most part, you get some pretty decent numbers to work with. Okay? So now here comes a tough question. Which is bigger, 16 or 9?
9.
16.
Why?
What number's bigger? Would you rather have $16 or $9?
I'd rather have
on the
one
denominator.
nine than one
I don't
16.
care. I'm just looking at the number.
Oh.
16 or 9, which one's bigger?
Oh, 16.
Remember, you're looking at the a squared term. It doesn't say look at 1 over a squared, does
It
it?
hurts my head.
So which way is this squished?
Horizontal?
It's squished horizontally, so it's going left and right. You guys see how it's a squared is bigger underneath the x? So that means it's going this direction. What I want you to do is as soon as you are able to identify what direction it's going, draw an oval in that direction. Trust me, I see so many kids do all the right work and then they screw up their graphs because they forget which way it's going.
Is it going to the right or the left?
Which one's bigger, 16 or 9?
Wait, it's going
It
to
also
the right.
says-
16. Guys, can I answer this? Hold on a second here. Whichever number is bigger underneath the x squared or the y squared, if it's bigger number underneath the x squared, it's stretched left and right. If it's bigger on the y squared, it's stretched up and down. That's all that means. Okay?
Centered on the order.
Yes, sir.
I kind of missed this. If it's vertical, how would the c squared equals a squared minus b squared?
It's the same thing for all.
Oh, so we got a negative.
No, c squared is a squared minus b squared.
Yeah, but if it's vertical,
A squared is always the bigger of the two numbers. It just means that a squared happens to be underneath the y instead, that's all.
Oh,
Okay. So now what I want to do, like I do in every one of these, is label a's and b's.
You're right.
So I know that a squared is 16, b squared is 9, and c squared will equal a squared minus b squared. Everybody okay with that? So if a squared is 16, what's a?
4.
4.
Negative 4.
So a is plus or minus 4. I have to do plus minus here because I took a square root over an equal sign. B is going to be plus or minus 3. C squared is going to wind up being 16 minus 9, which is 7. So what will C be?
49.
C squared is 7, so it's going to be plus or minus root 7. And that's fine. You're going to find out over the course of doing a few of these, a lot of times your focus value is a weird root, and that's fine. I'll show you. You're going to be surprised at how easy it is. So now I know that this is stretched left and right. I know my vertex starts at 0, 0. So what I'm going to do is plot just the XY grid and start from there. There's my center. It's stretched left and right, so my vertices deal with the value of A. So to the 0, I'm going to add 4 and subtract 4 to get to my vertices are.
So plus or minus a comma 0.
Correct. So my vertices then are at 4, 0 and negative 4, 0. I do the same thing with the co-vertices. I go up and down 3. And the reason that I know this again, John, you're kind of giving me the weird face.
I got lost.
Okay, remember, the reason I put that here first, so that way I know that my vertices are going to go left and right.
Wait, where did you get the vertices from? Like, how did you get those? I was ready.
Everything starts at the origin today. So if I'm starting at 0 and my A value is 4, I go right 4 and I go left 4. Because it's switched left and right.
Oh, okay.
Okay? Because that's the distance from the center to the vertex. Yeah.
So A is always the vertice and B is always the.
Correct. All right. And then my co-vertices at 3
That's it?
and negative 3.
And we just draw it?
We draw kind of an oval-looking thing.
That looks like a shark.
Looks like what?
I'm gonna draw shark fins on it to look like a shark.
Now, you were freaking out about this value of C because I haven't plotted my focus yet, have I? So let me ask you this. My C value is the distance from the center to the focus. Well, it just so happens that distance is the square root of 7. The square root of 7 is more than the square root of 4. Do you agree?
Yeah.
But the square root of 7 is less than the square root of 9, right? What's the square root of 9? What's the square root of 4? So somewhere between 2 and 3 and call it a day?
I like why. This happened.
Okay? I'm plotting it. I'm getting a visual idea of where in the world it might be because my last step now is to label everything. And here's what I do. I write down that my vertex was located at 4, 0, negative 4, 0. Now I know that in this little cheat sheet thing here, it said that your vertices were at plus or minus A, 0, or plus or minus B, or whatever it might wind up being like that. Write both ordered pairs out. The reason I want you to write them both out is when you shift things tomorrow, it's not always that clean. You'll have to add and subtract values. They might not line up as nicely. Okay? You'll see what I mean tomorrow by moving stuff. Okay? Co-vertex, those were at 0 and 3. Yes, ma'am.
Oh. You're probably going to explain it anyways.
What's that?
I was going to ask you, do you write it negative root 7 for the one that
Yep. And then lastly, my foci. My foci are located on the horizontal axis again. So that means my y values are both 0. So it'll be at root 7, 0, and negative root 7, 0. And you're done.
Do we have to draw like little words on the graph?
No. What you're going to do is you're basically, what I want you to be able to do is exactly what I just did. I wrote down the problem. I identified which one of these is larger, 16 or 9. I have a rough idea of where it's going to look like. And the reason I do that is so I don't screw this up later. Okay? Because it is so easy to forget which one you're dealing with. All right? It's not, hopefully it's not so scary. Yes, ma'am?
Do you like to do it like how you're doing the other day when you like wrote out the steps?
What do you mean?
Like how you just explained every step you did?
Yeah, that was, okay, you did that kind of yesterday, like 10-6.
Oh, like step number 1?
Yeah, I did that for.
Oh, I got you. Okay, all right. We'll try that. Let's try that. Same idea. 16x squared plus 4y squared equals 16. First thing I'm gonna do is make it equal 1.
Before we get started on this, why didn't in the last question, when it was the square root of negative 7, why don't we use imaginary numbers?
Because it's the negative root 7, not the square root of negative 7.
Oh,
Okay. Again, I want to make it equal to 1, so I divide everything by 16. So you have x squared plus y squared equals 1 over 1 over 4. I'm going to write it over 1, even though I don't really need to, because it'll help me remember what that number represents. Okay? So, step 2.
Going up and down.
A squared versus b squared. Who wins? Which one is it?
It's.
Which one is the a squared? A squared is 4 because it's bigger. Remember, a squared is always bigger than. Correct. Since a squared is bigger here at 4, I know that it's got to go like this. So right next to it, I'm going to draw an oval going up and down. Isn't this an egg also too?
I guess so.
All right, just making sure.
But that one's a wobbly egg.
All right. Now, in this case, I figured out that. I've got everything set up, ready to go. Now list everything. List all parts. So a squared equals b squared equals c squared will equal a squared minus b squared. That's what I mean by listing all of my parts out. I fill in the blanks. Notice, very sequential, very systematic. Not a lot of loopholes thrown in this one at you guys. A squared is 4. What's A? Plus or minus 2. B squared is 1, so what is B? Plus or minus 1. C squared becomes 4 minus 1, which is 3. So C is plus or minus 3. Very good. And then really lastly is plot. Plot and then label. That's really all there is to setting these things through. It looks like there's a lot more to it because those steps themselves there might be a little more thrown in there. So if I go to plot this out, we know that we're going through the origin still today. We'll shift tomorrow. Our center is at 0, 0. I know this is going up and down, so my A value is 2, so I go up 2. And I go down 2. My B value is equal to 1, so I go left and right, 1.
This one I made.
And now just to plot the focus. The focus is at the square root of 3. The square root of 3 is more than 1, but less than 2, I believe. About here. Here. The focus is always the distance, is the C value. It's the distance from the center to the focus. And since our center is located at 0, all I'm doing is adding the root 3 and subtraction root 3.
Wait, your focus would be outside of the ellipse?
No, if the focus was on the outside of the ellipse, then you'd have a hyperbola.
Elliptical.
Okay?
That makes sense. So then you're so the
High five, you're not paying attention.
will the focus ever be exactly halfway between?
It's possible. It is possible. It is completely possible. It's not a surefire bet. So now you've got enough information to list out your stuff. Your vertex was at 0, 2, 0, negative 2. Your co-vertex, 1, 0, negative 1, 0. And then your foci. Oops.
It's what's this?
I'm going to throw them through like that. About time. So,
No, it took us all a long time.
all right. That's how you go through this. What was it? Last time I remembered it was 15. Every time I remember to get it to him.
I was spending my time. Who cares?
All
Dad,
right.
he did on the test day. So
Now what?
Who cares? He did successfully.
I will. Give me 1 second.
Oh no, now he's writing equations.
So when we get out of here then, what we're going to do, just like we've done with all the others with parabolas, I give you guys an ordered pair or the directrix or where the focus was located and you wrote equations. We're going to do the same thing with ellipses. You're going to find out, once again, it's nothing more than identifying what A and B is by rough sketching a graph to figure out where things are going. Once you figure out where things are going, it's so fast to fill these in. Okay? So let me show you this. If I happen to have a vertex at 0, 7 and a co-vertex at negative 6 and 0, I want to write out the equation into what they call their standard form. That's these x squared plus x squared over a squared plus y squared over b squared, or the other one, depending upon what direction it's moving. So first thing I'm going to do is just kind of plot it to give myself an idea of where this thing's going. Now I know that sometimes people might pick out on it right away. It's fine. When it gets to the shifted ones, you're going to want to draw them. So if my vertex is at 7, 0, 7, and my co-vertex is at -6, 0. Which one of those two distances is further? 7. Because we're centered at the origin, so that means that this distance is equal to what? A, very good. So A is 7. Going to the co-vertex is how much? Is B, so B is 6. Now, notice that A is 7 is going up the y side. If B was negative, even if I did the negative direction there, when I square it, is a negative difference. I'm just looking at the B value being 6, okay? Now, I square them, so that means that A squared will equal 49, and B squared is, which way was it stretched? Up or down? Up, down, or left, right?
Up.
Stretched up, down. So where does the 49 go under? The x squared or the y squared? Y squared. Remember, whichever one is bigger is the direction that it's been stretched.
How do we know that this is not shifted?
Because it told you it's at the origin.
Okay.
Okay? So again, it's nothing more than getting the idea of where this is going from the distance from that center to the vertex is an A value. The center to a co-vertex is a B value. Okay? Yeah. The weird one comes in if I give you something with a focus. And I want to show you that one before we get run out of time here. We're centered at the origin still. We're centered at the origin. We have a vertex at -7 and a focus at -2√10. And I wanted to show you guys how you're able to figure out what B is. It's very easy to do. I want to make sure you guys see how this works. Okay? Just like we did a second ago, I'm going to rough sketch it to get the idea of what directions it's moving, so that way I know where to place A and B. Vertex at -7. Are we okay with that?
Yeah.
My focus, notice that the focus has the same exact y value. How's that work? So that means that's on the same line, isn't it? So it's got to be in here somewhere. I don't know where, but it's got to be before it.
So it's horizontal?
So I know that it's going to have to go like this now, don't I? Just from that. Now, could I get the decimal equivalent of what 2√10 is?
Yeah, -6.324.
What is it?
-6.324.
So 6-ish. It's before 7-ish, right? So I know it's opening left and right. So I know that the A squared term is going to have to wind up underneath. Okay. So I know it's going to be an x squared over A squared, y squared over B squared equals 1. So A is equal to 7, C is equal to 2√10. Is it okay if I get rid of the negatives?
Yeah, but you're squaring it.
Because I'm going to square them here in a second, and I'm talking about distance from 0. All right? Now, what's A squared? Yes, ma'am.
When A squared is greater than B squared, is it an X squared? Same or a Y squared?
We know that A squared will always be bigger than B squared. It's where it's being squished. If it's squished left and right, A squared goes under X. If it's squished up and down, it goes under the Y squared. Exactly. So here I know that A squared is 49. What is C squared going to equal? 40. Very good. 2√10 squared? Quantity, put it in parentheses. All right, put it in parentheses. Now, if I use the formula to figure out, C squared is A squared minus B squared. So 40 equals 49 minus what? So what's B squared equal to? What is it equal to? 9. It's not equal to 3, it's equal to 9. I don't have to do anything else but write the equation. So 49 and 9. It's a very common mistake that people get in the habit, oh, B squared is 9, so B is 3, and they write down 3. Don't do that. What's in the formula is B squared. So B there.
Or B squared?
They're so funny. It makes me want to cry and then not laugh because you're not funny. And you are.
Notice what I did here. C squared is 40. A squared is 49. 40 is 49 minus 9. 9 squared is B squared. I just didn't simplify any of it out because there's no need to. B squared is 9. All right. Remember, I don't need to know what B is because I'm not graphing it. I'm just writing the equation. Okay. Let me give you a few of these because I really don't have time to get this thing back. I might. What I want you to do is this is section 10.4. I forgot what page it is. You got your book. What section? 612, thank you. I want you to do numbers 612. 27 through 29, 57 through 59, and 63 through 65.
That's not too terrible.
The first three are the graphing. So graph them, label out all the parts like we did in class. The last 6 are writing out equations, whether you're given a focus vertex, focus co-vertex, or vertex co-vertex. There's a couple little twists there. Just remember what those values mean. Okay, just remember what those things mean. You're gonna go right. You'll be able to fly right through.
How long do you think this homework will take? Will I have enough time to do 10 minutes at home and then 20 minutes in class?
I don't know.
10 minutes.
Catherine Drew